Hello, just setting things up here. All right. One second. And there we go. Okay. So, all right. So, yes, welcome back. It's been some time. I had a lot of things happening. So I couldn't be on, and as you can hear, maybe I'm a little bit under the weather, so to speak. So maybe I probably won't be streaming for like 3 hours, 4 hours or something. We'll see. Maybe like 1 hour, 1.5 or 2 hours. We'll see. Cause yeah. But what I've been doing since last time is actually a lot of implementation in Runic. So, so what we actually added is, well, we have a whole bunch of tests. I did a little bit of optimization, even though I said I probably wouldn't do that, but I figured, hey, we got AI, let's just use it to fix some of the issues that we had. So basically, if you look at benchmarks, we have a couple of tests here. This one, it's like when the code is in a specific form, we can do certain optimizations, and I haven't actually looked at what the compiler actually does, but we have enough tests now to be sure that it won't actually break something else. So yeah, that was very important. Building like the test harness first, then go ahead and make some optimizations to see that we don't break a bunch of other stuff. Now if you run this, it's running pretty quickly. Like what it did before this was it took like 10 seconds or something. Now it's like very, very quick. But the thing is, there's like, if you have a loop with the process call in it, then it's still gonna be pretty slow. So if you run this, we have to wait. I'm not sure exactly how long it's gonna take. Maybe like 10 seconds or something. We'll see. And oh man, it took way longer than I thought, actually. Okay, there we go. So it took quite a while to do this, but it is correct, which is a very good thing. So because of optimization. So first, the AI actually tried to optimize this as well, and it was oh wow, that was really fast. But it turned out that it actually messed up something with the ordering here, so we had to revert that and go back to like fully evaluating this loop here. So yeah, this takes like, I don't know how long it took, but maybe like 10-15 seconds or something. But the thing is, like, if we compare it to bash, if we compare this to bash, and I'll use echo here, guess how long this is gonna take? Oops, bash. See, it's almost like instantly. And the thing is, it's because echo is a built-in in bash. So, but if we change it to use the actual, like we are doing it, we don't have a built-in echo. So if we use, like, you know, the process or the executable echo instead, then this has comparable. Well, it's still faster because it's like more lean, but it's still, it takes like way longer, you know. It's kind of comparable, but I mean really not. Like Runic takes longer, but the thing is, I don't think you want to do like processing like these too much in Bash. Like it's more other processes, they're gonna do a long type of processing. It's not like you probably don't want Bash to do this kind of thing, because usually like echo, sure, that just outputs the standard out. Like maybe you want to do something else, maybe you want to use some kind of other executable, then that's gonna take way longer. Okay, and then we have the command heavy, which is like a kind of weird test here. It's just a bunch of commands. This is pretty fast actually. I think the commands spawning has improved a lot. Of course Bash is gonna be way faster. So yeah, that's almost like instant, because Bash is basically just, it's like executing while it's parsing the thing. So yeah, and it's very fast, so it doesn't have to worry about, you know, compiling, running an interpreter, setting up the environment for all that. And but yeah, so let's say or type checking or stuff like that. I was actually thinking about this, because one thing that we could do is actually just transpile into Bash. So we just take the source code, transpile it into a Bash program, and then run it with Bash, because that would be very quick, and it will, I mean, if we make it so that it has the same functionality. We have the option of having other types of functionality, I guess, but you can always, you know, program Bash to make it have the same functionality, I think. But anyway, let's look at, so a little bit of optimization there, but let's look at the new features that I've done. So I'm not sure if how much I've shown, but we have like oh wait, this is the output file. So oh yeah, and this also showcases another thing, which is the environment variables. Now I went ahead and made them actually not ordinary identifiers, so they are actually now special kind of identifiers living in its own space. So this is actually, because environment variables are very special, like they change how other programs run. So it's like they are actually very special. You're like changing the context. Now these variables are just, you know, normal variables in this scope here, but this is actually, you know, it sets some kind of context. So it's like, yeah, I think it makes sense. Now the syntax, you know, dollar, I mean, it's like we're going back to the whole dollar thing, which I don't really like, but it was necessary because of this here. Because if we remove this, we don't know now if we're talking about a variable, an executable, a function, whatever. And right now it's gonna be parsed as an executable because, you know, it doesn't have anything in the scope called PWD. So it's going to actually be parsed as an executable call. And so then the result of this is gonna get into the ORL's you know, operator. But this, we actually now have to do this for environment variables, and this would actually produce a okay, so this would actually produce a string, or, well, actually it's an optional string. Yeah, so all environment variables are optional strings. So then you can actually, this is then akin to this, to the bash variant. Oops. The bash variant is going to be original equals, and then I think you do something like this, and then that, to get like the same thing. So basically, I'm not sure about the syntax exactly, but it's like you have this, I don't know what this is called, like some kind of thing, expression that you can put in here. So basically you put a variable here, I'm pretty sure, which could be an environment variable, and then you have this operator, colon dash, which means that if this is not set, then this is the default value, right? And so it's like either we take this if it's set, or we take this as a default value. And the same thing is here. So this is like an this is an optional string. So so we send it to or else this, and that has the same purpose. So either this is not null, which means the original we take that value, or if it's null, it's gonna be this value. So this is the same kind of thing. It's just we're using this syntax here instead. Okay. What did I change? Okay, so yeah, also I don't think we actually need to, yeah. So you can see here as well, we allow now variables to be passed in as arguments in an executable call. So, and I think this is gonna be a little bit, this is gonna be, you know, if you come from Bash, this is probably gonna be very confusing, because it's like you're seeing this as, if you're at Bash, you're seeing this as just a string original, but this is actually a variable, and strings are strings. Variable, like identifiers are never strings, like this. Hello, Matsevas. What am I doing today? I'm going through a little bit of what happened since last time. I've done a lot of things off stream, because I wanted to kind of propel the product. Like, I had such velocity, so I was like, hey, let's just add a bunch of stuff. And yeah, I'm just going through it a little bit. So that's the CD. CD is also like a built-in now. So it's a built-in, I don't know if it works exactly like Bash. Like, I don't know if Bash has like flags or whatever. Okay, so it doesn't actually have a bunch of options and stuff. Our CD is just, it doesn't have this. And if you look at what CD is, it's a shell built-in. There's no command called CD, because it's like a shell thing where you change the context of the shell. So our CD is basically just, yeah, give it a string and you go there. Hello, Sedu, how are you? I'm doing great, although I'm a little bit under the weather. Maybe you can tell by the voice, I'm not sure. But, so I'll probably not stream too much now. You can also do info CD, okay. I didn't know that. What is info? Oops. Read info documents. Huh. Okay, what's the difference? I mean, is this just another show info Emacs? So it's like a more advanced man thing, or did something happen? No, I just have some kind of cold or flu or something. I don't know. But it didn't work with CD. I don't know. Anyway, but this, yeah, you can pass identifiers, and I like this. However, it is going to be confusing for Bash users if they want to move to this, because it's like they are used to just typing this out like this, but this doesn't work. This doesn't work. You have to have strings. Like if you have literal strings, it has to be a literal string. If you have an identifier like this, it's gonna be an identifier. It's not gonna be a literal string. And it's like if you do something like this, then it's gonna interpret ASDF. Since it's not in scope, it's gonna interpret it as an executable and actually call the executable and then produce the output as an argument to CD. So it's kind of like command, I guess command substitution or whatever it's called, except you don't have any syntax for it. It's just because of how the evaluation works in the language. I stayed up trying to do homework, but I didn't do any coding this weekend. Okay, well, it's good that, I mean, that's not a bad thing to focus on. Good job. Sometimes I feel like, man, it would be cool to go back to school sometimes because it's just so chill. But then you realize that, well, maybe it's not actually that chill, and also there's no income. So, no. It doesn't work. Okay. Unless you're doing it in like extra, like maybe you can do it like halftime or something. I don't know. Anyway, yeah. So that was CD, and I got a little bit of everything. But we do have like test. You know, we have. I added a whole bunch of tests and stuff. Array access. Yeah, async. So now we have async as well. Yeah, it's not chill. Yeah, no. It depends on what course you have and I guess which school you go to and, you know, the teacher and everything. We had like when I went to university, we had like one teacher who I didn't even go to the class because the only thing they did was just go through the book like word by word. And I could just read that at home. Like, why would I go there and listen to this person go very slowly through the book? I mean, I know that I can ask questions and all that, but it just felt so inefficient to me. But yeah, I'm doing internship, going back to school. Okay. Is there go-to in Zig? Not go-to, but there are labels for, like, you can break out into a label or continue. If you have nested loops, you can do that. You can like do that, continue into another like label. But you can't just add a label anywhere. It has to be at a block of code, or you know, you have like a switch statement, a for loop, while loops, if statements. I believe. Well, it's technically I think it's a block that has the label. But yeah, there's no like, you can't just go to a label. The problem is I have no certification. What kind of certification? Okay, so here we have like async now. So you can have an expression like this. Now keep in mind, in Bash this would be like a subshell. In Runic this is not actually a subshell, it's just a grouping of expressions. So this would be just one command. And but it's run in, you know, the top level shell. So, or shell. We actually do have shell context now, so technically we are kind of morphing into a shell. But because we do have subshells now as well. But this one is not a subshell. It's just a, so if you did this would be a subshell here. Well, okay. Okay. So there's a bug with this. I have to fix that. Okay. I'm gonna add that here. What was it, like sleep echo, yes, or after or something. This one produces a parsing error. Okay, anyway, so this expression is like spawned async, so we're gonna continue, so we're gonna spawn this, then continue down here. So it works exactly like bash, and you know, it's gonna, if we only do that and we run it, you can see that after 1 is first and then bg1 is second. Okay, and then we have this one, which is similar. We pipe it into cat. This is run async, so technically all of this is async, and then that's after pipe. Let's just run the whole thing. So you know, first we have these two, and then in the second one we have after pipe, which comes first, and then bg pipe second. I guess it just showed that it works with pipelines as well. And then the third one, I mean, this is basically just the same as this, just a little bit good to have, you know, some backup or yeah, some repetition to see that it actually works as well. And then after block is run here. So technically, no, because we're sleeping here, yeah. But then bg block, so after block, bg block, so this one first, then this one. And then over here we have a job. So you can actually just, you can, you know, there's now like a promise type. I'm not sure if this shows up here. Execution. Okay, well, it's not actually. Okay, so this is an execution type. I'm not sure exactly how the type's gonna work, but basically this is just, it's just a placeholder. It could be as well, but this is spawned as an async thing. We have before wait. You can say bg wait is actually called, you know, when we wait for it. So we call wait here. Okay, I actually see an inconsistency here, because this should technically happen before. So I'm not sure why that happens. That could be a race condition between actually implementing, or it could like actually running this. No, because we should wait for everything to be completed here. So this is actually a bug here. Yeah. But then at the last thing we print out. Oh, sorry. No, it's actually not a bug. Okay, sorry. So what's happening here is like when we do this and bind it, this output, if we didn't bind it, this output like up here would go to standard out, right? But since we're binding it, we now store the output as well in memory here. So it won't actually go to standard out. So when we wait here, it actually doesn't actually echo this out. We have to, you know, printf this thing. So we can capture it from standard out. You don't have to say standard out, you can just do this. In fact, I think we can also just do this now. Yeah. So at the end here, we actually print this out, but yeah. Okay. What built-ins do you have? So we have CD. I mean, Bash also has async. Like Bash, this is the same operator that Bash has. It's just that it's a little bit more involved if you wanna do things like this. I think you can't get the. I mean, yeah. So the equivalent would be like getting a process ID, which is actually the operating system process ID. Like this one has also like a process ID, but it's like an internal ID that we manage ourselves. So, but the Bash, they have like a proper, you could say, like process ID when they spawn things like this. But they can also do things like this and get. I mean, if they want to bind it to something in memory, I think you could also store it in like one of those file descriptors, like redirect this to some kind of file descriptor or something. But it's an easy way to launch something in the background, and then like say, okay, now we want to wait for it over here, and then we can also print the job. I'm not sure if I'm gonna have a mode where this gets executed at the top level, like the output, and not stored in the thing, because I don't like Bash right now. I think always outputs to the top level scope, unless you, I guess, redirect it. But yeah, that works. What else do we have that we added? Match is new as well. So match was a thing, and the syntax has not been implemented yet. So but it works, like it compiles and everything. It parses and compiles. So it's just that the syntax highlighting is not implemented, which I should actually add in the to-do as well. Syntax highlighting not implemented for match. I'm not sure if there are others as well, but we'll add that as for now. So basically, it's gonna be like you're matching some value, and then you can have literal values. So if it matches 1, this is gonna be executed over here, and 2, this is gonna be executed, or this, which catches everything. And of course it works with strings as well. And well, here it's like a string in a variable. Here it's just a literal string. And we can also pass functions here. So this is a function here, which is just is hello, and it just returns, you know, it just checks if value is hello. And so you can match on this function to see if it matched or not. So it's just it basically is a fancy if else thing. I mean, just like a switch, sort of. Except switches usually, when you have things like this, switches usually have something called a guard. But this is more like, or maybe not a switch, maybe that's like a case thing. But this is like a match. The idea is to have something akin to what, you know, Bash has. But Bash also has utility of like globs and stuff like that, pattern matching with regex, regular expressions and stuff. I feel like in this my country, people don't care about the competence when it comes to programming anymore. It's all about paperwork and whether or not to use LLMs. Oh, really? Already? Oh, man. I've been out of the loop a little bit, but... Alright. In short, I just am studying not to really learn stuff, because I always believe that these courses were a scam. Oh, shit. I mean... The school that I went to wasn't really a scam. It's more to get like an official... what's it called? Not like a diploma, but you know, as an official, you know, paper that says that, hey, I went to this school, so I have some kind of basic knowledge. The truth is though that you don't get a lot of knowledge from school. It's like you get some kind of basic. It's just, yeah, it's just super basic knowledge. And then, you know, which you will learn if you work and learn it at work. So, but I guess it's just to make sure that people have some kind of basic knowledge. You could also just as well just know a lot about computers or be interested in programming from before. Or both. That match looks oddly like Rust match. Okay. I haven't actually seen that, so... Also, you can match on null. So null is a keyword. It's like a special value for null. Of course, you know about null. And here's for booleans as well. And this is kind of weird because it can't really be something. Well, actually, technically, we're matching on an exit code, so technically, the type here is actually not a boolean. It's an exit code, which is kind of funny. But it's like this is 0, this is 1, and then this could technically be anything else. Like it's a byte actually. So especially programmers very democratized. You're not limited by economics. I invest a ton of money time in books. So I'm only doing it to get my rights as an employee, not to get bullied, not to really learn anything, but I hope that I learn. Oh well, if you're getting bullied, that doesn't sound like a good working environment. Like I know that some countries or some cultures, like working cultures, have this insane thing where it's like, well, if you're like lower class, even if, and then you have like, because we had this employee where I worked at one point who had like a supervisor that was not actually as good at programming, but he couldn't actually say anything to that person because that person was like the supervisor, and in that culture you couldn't actually criticize your supervisors at any point. And of course in a lot of companies that's gonna be the case. Like you're gonna be careful of like doing stuff like that, but I feel like some cultures have it worse than others when it comes to that. Will Runic support classes or structs and enums in the future? That is the, well, maybe not classes, because it's gonna be like a zig style, but the idea is that we're gonna have structs and enums and tagged unions, just like zig. So basically it's gonna be like zig data types. However, comp time I'm not sure if we're gonna have. There's gonna be like internal comp time of course, but like userland comp time stuff we probably don't. We're probably not gonna have. But then I'm not sure what we're gonna do with like, generics, things like that. Would be cool to have. A bash scripting language with generics, but I don't know. We'll see. I might actually leave it like how it is right now. And one thing that I would like to do, which I'm kind of looking at here, because I asked Claude to make a plan for modules. We had modules. I think that modules are not working anymore. But that's the next plan to implement. What else did I do in the meantime? Yeah, environment variables. As I said, here's a little bit more more things here with environment variables. Environment variables are always like this. It's not like bash where sometimes you have the $, sometimes you're not, depending on the context. Here, $, identifier always means an environment variable. If you set it, that's gonna set the environment variable in the current context. If you use it like this, it's gonna be interpolated here. Also, this is actually this is an expression here. So this is like the like the thing we looked at before, like colon dash equivalent, where if home is missing, we're gonna use this one here. And this one is just, we're using an existing executable called printEnv to print this environment variable to see what it is according to something else. And here's a subshell. Subshells are denoted with this. You have $, and then parentheses, and then we have an expression in here, and it can be a block expression. and in this case it is. And a block expression is, you know, a list of statements. You can also just have one expression in here if you want. Now here we're kind of doing the same thing. Here we're setting home to be something else, and we're printing that. I'm not sure if, like, setting home seems like a dangerous thing, but it's just testing here. So I'm not sure why we chose home, why AI chose home here, but it's setting it to something here, and then we print it out, and we're trimming out of the new lines, and then we're echoing this. So we're setting this subshell execution to bind to this, and then we echo that out, which we can actually do like this now, which is nice. What else can we do? I think we can technically do this as well, although I would probably group this. I'm not sure if this actually works. It does work. Okay, well, let's see. Running parent home or else missing. Yeah, so that does work. You can actually, this is one argument to echo here, so that's pretty cool. Yeah. All right, so let's see, what else do we have? Oops. I added, well, subshells. So subshells are ran in a separate shell context, which means that in a subshell, it tries to mimic like how Bash works with, you know, you have a subshell. In the subshell, if you change the directory, it won't change the directory of the current execution of the outer, you know, context here. So this CD changes from the outermost context, and then we get the original back here. Now this wasn't really necessary to be run in a subshell because we're not actually changing anything here. So, but whatever. But this one is like we're entering a subshell and we're seeding to root, and then we check, okay, what's the output? So that should be the same as this output here. So if we run this, we can see that first we go to temp, print that out. Then we go to the original place where we were, print that out. Then we have a subshell which sees the root, prints out this. And then we have the last thing, which, yeah, that's basically the same thing in a different way. Again, we can just do this now, and this. Yeah. All right. So that's pretty good because subshells are pretty useful if you wanna start off some thing in another place. What else? Optionals. So now we have optional types. So optionals with null, we can or else to get a fallback value. Actually, I'll just do this. This should also be faster, I believe, because we don't create a string. We just have this. I'm not actually sure how it does it because that was all AI making these arguments here. I'm not sure like if this is more readable though. I don't know. It's less noise. But yeah, really cool. We had the or else, you know, default value. So yeah. And all these tests have like standard out here. So it's like we're saved how it should look. So if we run the tests, we can see that everything still works. So this is a thing which just runs all the tests here. Apparently I didn't compile. Now you can see some of these tests are actually pretty slow. So that's why I wanted to look at the optimization at least a little bit. I mean, yeah, as I've said many times, like I don't want to spend a whole bunch of time on optimization because I don't think it's super important for this type of language. Is there an envar that keeps the current working directory for the subshell, or is it stored separately? Well, you can get it with the command pwd. I'm not sure if that's... Yeah, that has to be an executable. Oh, it's a shell. Wait. Okay, so it actually is executable and a shell. But as you can see from CD, you know, it actually does change. Like we call CD, pwd is not a built-in in Runic. We actually just call the executable. So it does change the directory for like the current process, I think. Otherwise this wouldn't have worked. Or I just misremember, we actually do have a built-in for this, but I'm not sure. But actually no, the thing is like, we changed the directory, so every executable is called is actually spawned with the current working directory set to whatever we have in the subshell. That's how it works, yeah. So this would this would have the current working directory of the correct, like of this context that is being, you know, called from. Yeah, who decided about the if and fee thing? I think that it's just because it's so old. And back then, I mean, I'm just guessing. I don't know, man. There has to be a good reason, but you know, the thing about Bash, I've said like many times, or like every feature that you learn basically has its own syntax, and that is why I don't really like it, and I don't want to like memorize all those different things. I want to have it more consistent. That's why I kind of made this language here. But this is probably never gonna be as, I mean, yeah, this is never gonna be as fast as Bash, unless we, instead of trying to compile, we do a transpile to Bash. So it's gonna have a larger startup time because it has to like type check, compile, and everything. And then, or just compile. We can skip the type check as well. If you want to have type check, it could just be like in the, when you're actually editing the script, it runs the type checker. But when you actually compile it, it doesn't do that. But I think also like the compilation, some things actually depend on the types to be able to know how it should compile. But if we just transpile it to Bash, so basically we take the AST and transpile that to Bash. We create a Bash program out of the AST and then run that with Bash. It would run as fast as Bash, but it would have a longer startup time. Now the startup time of this was about like 40 milliseconds or something like that. So it's not that big of a deal. And once you've started it up, it's gonna run pretty fast. I guess that also the 40 milliseconds was also for a very small example, but so maybe it will take longer if we have like modules, you import like the standard module and you import all these different libraries and whatnot. I'm not sure how long that's gonna take for compilation. I guess we'll test that out. What do you think about PowerShell? So the PowerShell, I mean, I don't have a lot of experience with PowerShell. The little experience that I have is like, it's kind of like, it feels like kind of like a mix of, you know, Bash with, well, maybe not Bash, but basically some kind of weird scripting language with C#, What I do like about PowerShell is that it does have like very nice like auto completion. It does have like types, and you can actually like sort of inject C# code, and so you can do a lot of things with PowerShell. That's really cool. But also some of the syntax is like it has like the same problem as Bash, because it's like, I don't know, and I just can't figure out. I also have to Google every time you want to do a specific thing in PowerShell. I also have to Google it. Loops. I mean, it's probably a little bit better than Bash, and I'm not saying my language is better than PowerShell or anything, but I don't know. It's just I always have to look up how to do things, which is why I wanted to make Runic more like a quote unquote real programming language that has like, you know, not these scripting. Not the scripting feel. It has like more of a feel of an actual programming language. But then with like embedded sort of command execution in it as well. Sort of is how you can look at it. Yeah, and PowerShell is bloated. Yeah, I mean, yeah, there's a lot of stuff. That's also every time we do something with Microsoft, that's what you get. You just get a lot of weird things that you don't understand. Excuse me. All right. So, okay. Let's see. I'm just gonna go through here because I don't even remember everything that we added. Oh yeah, semicolons. Actually, now. This wasn't here before. You can now have semicolons if you want to do one-liners, which is really nice if you want to do, you know, you can do runic eval. Usually want to do this because strings are always double quoted for now. But let's say we do, you know, CD scripts. Actually, okay. There you go, and then list. And we get the scripts there. So that's nice. Yeah, this just showcases all of that. And we can also have them in parenthesized expressions. However, this does not work if I am correct. I'm just gonna check if this works. And this does not work. There's some kind of parsing error here. So we need to fix this, yeah. Recursive functions did work before, now it works again. So recursive functions are actually working. And then what else do we have? Exit keyword, yeah, I've shown that. Redirection, I'm not sure if I've shown that, but we now do have redirection to files, standard out, standard redirection. We don't have arbitrary file descriptor redirections, but we have the basic things. Script arguments, this is also good. You know, here's a script here which takes message, and I've shown this, and this is an argument to the script, and you should define the arguments to the script explicitly, and then they get bound to an identifier. So that is really nice. I really like that, in contrast to how Bash does it. Okay, is there anything else that I just want to show real quick here? FD redirect optional. Array access. I don't think so. I mean, optional unwrap, chain redirect, comp time folding. So yeah, that's the, I think, optimization, maybe port. Yeah. Anyway, yeah. So a lot of things. I've just asked Codex. Also, I have a little bit of update. Codex versus Claude is like, okay, my verdict is this: Codex gives you a lot more tokens, and in my opinion, is actually way better than Claude Code. Now, I don't know if I'm using maybe the wrong model. I'm using the default model for Claude, but I've noticed that it does like these weird errors. I'll show you one here. I'm not saying that Codex is always perfect, but this was like very apparent to me. Let's see. No, it's, wait, it's down here. So I asked it to plan a module feature. Okay, and I gave it examples here. So here's like a signature for the file where it says there is a function, takes nothing, and produces a module, and it has 2 arguments. So this was just an example to get it out to understand. Okay, and that's very good when you do that, especially in code. It just knows exactly what you mean, basically. Just give it an example and it can extrapolate that. Okay, so very explicit here. And then, of course, the type is module. And then we'll see what it says here. So it had a bunch of questions here. Yeah, open questions before starting. Pub signature, blah blah blah. Here, module keyword. Module as a return type. Is that the spelling you want, or do you like something like module with lowercase? Matching Runic's other type keywords like void. Does this look lowercase too? So that, yeah, I just looked at this here, trying to make sense of this. But yeah, I mean, I'm not saying Claude is bad. It seems to do a good job. But things like this, I have never seen like Codex do like a mistake like this. But I mean, it's like it's getting confused about this module keyword. Maybe it's because it was too much to process at one time. Maybe, I don't know. But it's kind of funny that. Yeah, sorry about Nightbot there. I'm probably gonna remove Nightbot, to be honest, or remove some of those things. You should be able to post like all caps. Just don't spam. But yeah, so I just kind of find this a little bit funny here. And you know, sometimes I've seen Claude like enter some kind of path where it thinks it's doing the right thing, but it actually missed a bunch of context to be able to do the correct thing. So you really have to guide it to do the correct thing, which is also like, you know, a tool usage issue. But as long as you kind of guide it correctly, it does appear to do a pretty good job. But I will say that Codex gives you way more tokens, and I just yeah, I feel like you don't have to guide Codex as much. I just have way better feeling with Codex than Claude. I don't know why people are bashing on Codex, to be honest, like and saying that Claude is like way better, because I don't know. As I said, I use the default module. I just don't want to use a model that like uses even more tokens, because then, you know, how I'm not gonna get anything done here. But yeah, anyway, I asked it to plan like a module system thing, and it came with a couple of reasonable things that we could do. Here's like it listing out, and that's what I was thinking, like maybe we'll do a little bit of this in the stream. like we'll try to make the module system as per how this plan. Now I haven't read the entire plan here, but I will go through it, and you know, if there's something weird going on, I will point that out and we'll figure it out. So anyway, here's what already exists. Script signature parsing. So yeah, so we already have, and I was talking about this signature for the script function, because all scripts are basically functions, because you call them and they get executed, and you can pass arguments to them, and they have an output. So they are basically functions in Runic, and that's the same with Bash. And also, I find interesting is that Python also has the same execution model and importing. If you import something in Python that's like on the top level prints something to the screen, it will actually print that to the screen. So it will actually execute the code directly. So it's kind of up to the user how they want to define the files. You can import something that executes things directly, just like in Bash or Python, and that will actually just execute those things directly when you import something. But you can also design it as just a module that exports a bunch of declarations, functions, and stuff. So anyway, we already have this signature parsing. We have the AST. We have a compilation for it with binding the arguments in the compiler. So all that works. A thing that doesn't, I guess we have to kind of incorporate the import expression to work with this as well. Request module scope run module member access. Type checker already resolves imports to scope. Yeah, so the type checker is done. Parse imports already recursively pre-parses. Yeah, so we're also, you know, when you import something, we also like parse those and compile. Like, yeah, we're including them in the thing, the compilation and parsing and all that. Value struct. A runtime struct value already exists modules we reason. Now this is, I'm not sure about, because we don't actually really use this that much, I don't think, right now. I think it's like a dead type. I'm not sure. We'll see. What kind of instructions do you have in your IR? We have instructions. Type. Here are those instructions. It's kind of like a mix between, you know, assembly code and more abstract, high-level things. So we have this thing which is like a setup that all programs do at the start with setting up like the main, I guess, like shell context. We have push, which you push a value to the stack. Pops a value from the stack. I have like ink and deck, which were useful to have at some points. Excuse me. I have these ones, which are like binary operations, arithmetic. So I compress like all arithmetics into one instruction, and you basically just replace the binary operator. So you have like the operator, which is an arithmetic operator, add submod division mod, and then and then it's like a binary operation. So it has, you know, left hand side, right hand side, which is called AB for some reason here, but whatever. And then we also have the result, which is, the thought here is like you can decide where does the result end up. Some assembly, some like CPU architectures always put the result in like racks or the A register. I guess depending on the size of the operands. But I have this result here, so you can choose where to put the result. Same with compare, except now we're comparing A and B with like, you know, less than, greater than, equal. Logical, which is called log here. So that is, you know, and, or, not. Well, actually not is not here because that is a negation. Actually here neg is like negation for logical. This one is weird because it was like I wanted to have a labeled local variable which is put on the stack. So what this does is actually just pushes on the stack, and it also now we have a label for it as well. So we're storing this label so we can like see what it's, a little bit for like debugging information as well. Set is just, you know, it's kind of like move in assembly. It just sets a location to a value, or yeah, a value from a location. Jump, we're jumping somewhere. So what's also important to keep in mind here is we do have a program like execution context, which is kind of like, you know, you have the registers. You have register. So I have two general purpose registers, R and R2, and R is used for also return values. So R2 is like the only like real general purpose register, which can be any value. And then you have the instruction counter register that you can just set to something if you want. You have the stack counter and stack frame registers, and was there something else? I don't remember. I don't think so. Anyway, yeah. So we do so, and then we have and then these are more abstract here because these are more connected to being able to easily, you know, create sort of like pipes or file descriptors that we can write to and read from and stuff like that. So yeah, so we do have that. Yeah, there's a lot of stuff, and then fork, of course, very important, which is just spawning a virtual thread in our machine. So to be able to run things asynchronously and yeah, very very important. Also, it's also potentially like a place where you can change, for example, the subshell or redirect to something else, like standard out, you know, to a file or whatever. XX spawns a process. Wait for either a thread or a process to be done. Yeah. Allocate. This is also like abstract, you know, we allocate n number of values, so we can allocate structs, arrays, and stuff. Yeah. So a bunch of stuff, basically. Maybe I went a little bit too far there, but anyway. Okay. So, should we start with this one? So, basically, modules use the pub keyword to expose a declaration to import, like where they are imported. And so, it's basically exporting a function or a variable. Oops. There's a type in Zig. Well, this is just my type here. I just happen to call it type, but there is actually a type in Zig. But it's not like. Well, okay. So the type in Zig, you have like standard built-in type. Now this is used for comp time stuff. So this is like you have all the types here in Zig, and this is what you use if you want to build a new type using comp time in Zig. So you can actually do that. which is really cool. But this type here is just a name that I happen to have the name type, because I want to have like an instruction type, and that's the type of instruction. It's basically because it's namespaced. I don't have say instruction type, but really it's like inherited here, sort of the name that I'm thinking about. So type on this struct is like instruction dot type. Yeah. Sometimes I like that structure. Sometimes you can put this outside and call it instruction type instead, something like that. But let's see. Should we start with this one here? Hello, Joe. Are you using Archie? I don't know what that is, so no. What is that? Okay, let's do this. Let's add the public keyword. So we'll go to the Lexer. Actually, we need to go to token first. And there's like keyword somewhere. I'm not sure where to put this. There, it's like, I don't know, let's just put it declaration. I mean, maybe it's part of declaration, I guess. Because it's like a declaration modifier. Pub modifier. Alright. And now we should get a bunch of errors, probably. Okay, so let's go to Lexer, and we have things like, whoops, that was bad. Wait, this is testing. Where do we actually do this? Keyword map. Where is the keyword map? Oh, it's over here. Okay. So add pub here. There we go. It's an operating system. Okay, it's similar to Arch Linux, but was made for developers. Okay. Well, I'm using. Excuse me. I'm actually, my host operating system is Windows, and then I use WSL to run Ubuntu terminal based operating system on WSL. Has many quality of life features. Okay, cool. So unless you can install it using WSL, I suspect you can't. Maybe I'll switch to, no, wait, Arch. I'm checking with Microsoft Store, because that's where you get these things, I guess. If it's gonna work with WSL. But I didn't find Arch or Arch either. Anyway, because it's just because if I try to run Linux in like what's it called, a virtual machine like VMware or something like that, I can never get it to work properly. So I would rather just use this, because this works very well. So okay, what could you give me some examples of some quality of life features that you like from Archie? Is it Archie or Archie? Archie, because people say Arch. WSL, yeah, that's what I figured, but you never know. You could check. Okay, so we got that. Now it's saying go to parser and yeah, so but do we have those? We should do this first before we do this. So this was in binding declaration, right? Is public. I'll put you over there. Function. Sure, let's just put it at the top. Keep it consistent. All right. Now we have a bunch of parser issues. Parse function declaration, I would assume this is. So we have the function keyword. Actually, it should start with the public keyword. So, I mean, let's do this. If we have a public parse, I'm gonna do parse by. Right. So we need to consume the token. And then we're gonna look at next and a switch. No. So it could be either be function. Actually, you know what? Let's just pass this in. You know what? Let's do pub token as a no optional token. And start would be either well, so function token is gonna be this. And a start is either going to be pub token or else function token. Because now we can just call this with parse function. And then we have the pub token here. All right. There we go. And then here we have to pass null because we don't have one. What language is this? This is Zig. Zig. Z-I-G. Just like it says over here. Archie. Archie. Like OM Archie. Like oh my god. Unlike Arch, which you have to take a lot of time to set up, OM Archie is essentially ready to use. Arch can take a long time to set up and polish if you don't know what to want. Just get Arch KDE and then you can install as you go. Yeah, I mean, I don't know what's wrong with me, but every time I try to install on like a virtual machine, on VMware or whatever, I always run into some weird error when trying to do just basic things. I can't even give you an example because it's been so long. Or just try to install it like on the actual computer, like dual boot or something. But I don't want that because I wanna develop and then in the next second I might wanna play a game or something. And I don't wanna have to reboot into Windows to do that. Or develop while playing a game. Alright, so now we should also do, I think, var and const. Where is that actually? For match identifier import function. Where's the var and const though? Oh, that's not an expression, right? That is actually right. Okay, yeah, because I've done this a little bit weird. We have statements and expressions. Statements are a little bit different, and bindings are like almost the only thing that is not an expression. So that is like specially handled over here. We may have a type binding. That's just a, yeah, I don't even think we have support for that. And then we have the binding. Yeah, so we should probably just add this over here instead. Like we have a pub keyword. I'm also gonna do the same thing here. Pub token, question mark, token. If we get this, we will do, we'll go recursively in here with now a pub token. No, next, I think. But if we already have a pub token, then that's gonna be like an error. I don't know. This is kind of weird, but whatever. So we report expected const or var actual this. But we didn't expect a type. We expected keyword, I guess. Gaming on Windows makes sense, but I just hate Windows 11. Yeah, you just have to deal. You just have to live with it. Like the weird stuff they're adding to these operating systems. Like the only thing I use is I use the start menu and the taskbar at the bottom. But they added like I don't know what they're doing with some of these weird extra things. Error, bang, question mark. Sounds very funny. Yeah. Is it an error? No, it's a binding declaration. So this is a, you know, it's a union, error union. This part here, well, the bang, you can see it as the left part is the error type, the right part is the value type. The bang is saying that this can be an error. The question mark is part of this type, which is an optional binding declaration. Excuse me. All right. You know what? This is weird. We should just expect the next to be const or var. Maybe we don't call this recursively. It's just so we don't have to redo this path here. Also, we need to consume here as well. Do we consume here or actually? Yeah, I think we consume here. No, we just do that. Consume it. Where's the error? Okay. I don't know. The LSP gave up on me here. What games do you play? Right now, I started watching a Valheim playthrough, so I started a rerun on Valheim. I haven't actually finished it yet, and I haven't played the new like Ashlands stuff. I did Mistland. I came up to Mistlands. I don't think we cleared the boss though. But right now I'm in the mountains. Sorry if I spoiled anything there, but yeah, it's an old game. But yeah, and I don't know anything about the new stuff after Mistlands, basically. And I also play a lot of Hearthstone or Battlegrounds, not the actual game. Well, I say a lot, but it's really not that much. It's as much time as I have extra. It's not a lot. Yeah, if your LSP does it, yeah, LSP restart. Yeah, I know. But I think there is something. I think what I'll do is I will just exit out and go back. Because it was a bunch of other files loaded, and I know that some of these files, I don't know which one, or if I have to open like a lot, makes the LSP not happy. So, where were we? Finding. Yeah, even now I can't like go to this thing here, and I can't now. Okay, the LSP already gave up. It already gave up on me here. Okay. Oh, there we go. This is the problem here. Wait, so we don't actually have these done. I think else we report an error. No. Yeah, we expected a keyword. It was function. Actually, this is kind of weird because the pub, I don't think it's ever gonna go in here. In this else here. No, it can. It can. Yeah. But okay, yeah. I don't think it's ever gonna show this error here. We're not actually part. Yeah, we're not supposed to show this. No, yeah. Because this was a pub. But I think what we need to do is say this. Maybe. it's kind of weird because this is actually parsing from the statements parser, while the other is from the expression parser. But okay, if we get this, we consume it, we check if we already had one, then we have an error. Otherwise, we try to parse this again. And then next time we should get const or var. Or we don't get anything, which then later we'll go and try to parse a function with parse pub, which parses a function where we give the pub token there. If we don't get a function keyword, that means we don't have const, we don't have var, we don't have function. So actually this should be the same error message here. Alright. And this is null. Oh yeah, if this is not equal to null. Right, now we're missing is pub. Wait, where is this happening? Parse binding. Ah. Okay, yeah, so this should also, we should pass the pub token along here. The reason why I want it to be a token is because of debugging information, so that we can see the whole like expression. There we go. All right, you want to have this as well. And yeah, we should have that. Okay, so now we have the pub token. So we should actually be able to parse that now. So if we run, for example, I'm gonna do zig build first to see that everything is working or compiling. So we'll make like a pub function. Oh, I always use double quotes. And that works. It doesn't really do anything right now, but it does. It does. It does work. Let's do not eval, or yes, eval, but then also just print AST so that we can see that we actually get. Well, okay, we don't actually see that it's public because we don't really say that here. I guess we can include that. Where are we doing this? Printing implemented. So if it's public, we could just add it before here. Just a modifier. No? Why is that not working? I did build, I did run it. Okay, this is okay. If it's not equal to null, this one just has null, but this one consumes the public token. We get the next one. If it's a function, we call it with token, which is a token now, so it should be populated. And then it should be set down here. Okay, let's do like else not pub, just to make sure that we have something here. Yeah, okay, so it does say strange. Okay, let's go back. So parse. So first it goes into like parse statement really, and that goes into binding. Now this one actually does consume the public token, although okay, I see what's going on. So we're consuming it here, but we don't restore if we don't find it, or yeah. So we don't actually restore this one. Now we do have a try parse, or do we? Well, what we do is we take a snapshot. Where is that? Oh yeah. So we do this. We take a snapshot here. And if something goes wrong over here, we return null. Well, then we restore the snapshot. Yeah. Wait, no. Yes, and then we return null. So that the parser is now restored. Okay, it didn't work. I do realize that we go in here again, take another snapshot. It looks at the next thing, and it's not a function. So we restore this snapshot and return null, and then this returns null over here, which means that we don't actually restore the outer snapshot. So now this is too stupid right now. So I'm gonna do this to make sure it works, but this needs to be rewritten here. Yeah, now it works. But this is very spaghetti right here. Because we're calling this function again. We have like multiple of these weird exit points. We consume the token. You know what? We probably only need to... whatever. I'm not gonna fix it right now. Okay, and then we remove pub. That gives us the normal function now. Yeah. Okay. Cool. Very, very awesome code. Okay, so now we have public keyword for the function. I'm gonna also add this to the binding declaration as well. We do have like is mutable as a thing over here, but I don't know. Let's just do it like this. All right. So now we have like pub const x. So this is a public. If we remove it, we can check with vars. That also works. And with a type. Yeah. All right. So we have this keyword in now. Okay, so these are done. This one, scope type checker. Scope type checker, add pub to scope binding entries, run module member access, filter lookups. Okay, to only is pub entries, sure. And also like Zig has a warning or an error, not a warning, an error. If you're trying to access a private entry, it will actually tell you that it's a private entry. Otherwise, it's gonna be like it doesn't exist. That's a different error. But I guess we'll only filter it for now. So let's do that. The scope. Is this used by the type checker? I'm not sure if this is even used, to be honest. Or no, okay, yeah, it is used. Yeah, okay. Because we did have another scope thing, but this is different. Yeah, okay. Binding. So maybe this should have like is pub here then. There we go. And add that as well. Global scopes are, I guess they are public. I do declare. And true. And what is this? Type binding. Oh yeah, type bindings. I mean, they technically they should also have is pub, but I'm just gonna set it to true for now because I don't want to bother with that. And here is the pattern. Oh wait, this is a binding, but wait. Function declaration. All right, let's just add. This is kind of like a strange thing. But okay, well, anyway, I'll add. I can't think straight right now. I am probably gonna quit the stream pretty soon here, but let's just get as much as we can here. Function declaration. We already have that. And what is this? Function. Okay. Wait, is this? The same? I guess. Wait. Yeah, I guess so. Wait, but we're declaring the function here. These are actually not public. No, these are not public. These are the parameters. Like, what we're asking is basically, okay, if you have a function, with parameters, are the parameters going to be exposed as public declarations when you run the function and get like variables out? So that is probably gonna be false. Maybe we'll have a pub keyword for those as well. I don't know. What is this? Binding declaration. Should really have a convenience function for that, probably. What is this now? For expression source, right? The for expression. Yeah, it doesn't make sense for these to be public. Let's just make these false. It's like the capture identifiers. Basically, all identifiers now that we bind in some way get this modifier here. Condition optional capture, I think, are not public. Condition type, what is this? Capture. It's also capture, I think. Okay. So the scopes are done. So I guess it's type check only. Okay, well, it runs at least. It doesn't crash for the basic thing there. Okay, so I think we've done these now. The type check, well, the type checker scope, I think that's the same that we did. Yeah, we did stuff there. Run module member access. Okay, there we go. Run module member access. So this one we need to filter. We need to filter the things. Oops. Module scope. Module. Right. This is also a little bit strange because, I mean, yeah, I don't think we're actually gonna have this type anymore. Maybe, I don't know, because the thing is that like when you import a runic file, it's gonna be an execution result actually, and I think that part of the execution result is that it's gonna expose these declarations as well. So usually an execution result has standard out, standard error, the merged output, exit code as well. And so, but now what I think we should do is we should actually not really have like a module type, so to speak. It's actually just gonna be like you run the function and you get an execution result back, and then that execution result is gonna have this scope on it that you can access. That's what I'm thinking there. But yeah, I just feel like I can't really continue here, unfortunately. But we've done the first pass here, and I can just ask AI. I was thinking like, hey, we already have the plan here, so we just need to put it in motion or start working on it. Of course, then we run into this, which kind of does not really align with my idea of how this is going to work, which was always the risk here. But I think that a lot of other stuff here are probably correct, and we're not going to have a module keyword. Yeah, we'll probably remove that actually. That idea, and then we'll have like it's just gonna be like this. You're gonna have like, well, let's do like module rm. So how it's gonna look is that you define the signature. Now void here means that standard, we don't take standard in, and then we have at for the script file. And here's argument, so you can put, let's just say for the sake of this module to show like how would you would use it. So basically, actually, you know what? Let's just say you don't take any arguments for now. And then this should be void here, because this type is really not like what we return, like what you get when you call the function. It's what you get as output when you pipe the function. And since this is just an import, it doesn't actually pipe to anything. It's just going to be void here. Hello, Blue. Yeah, I have like some kind of cold or flu or something. I'm gonna quit here actually. Also, sorry, I forgot to say thank you, Piano, before. Sorry about that. Maybe, I don't remember. So this is how it's gonna work. We're gonna expose this here, and then you have something like, you have like functions, greeting, which does output perhaps a string, hello world. So basically, since nothing is outputting anything in the direct top scope, we don't actually have, this is actually not set to any type. Well, it's set to void. But if you had something like this, initialized module, then it would need to have a string type here. Now we don't have type checking for this right now, but basically this is sort of how it would actually be. Actually, this would probably be like an error type, since any executable could potentially result in some sort of error, which we don't know about. So this is gonna be like some kind of error string type or something. Actually, it's like whatever. So basically something like this, but so that's what this type is for. It's really not like a return type. It kind of depends on which context you're talking about. Or you're talking about the context of a pipeline, then it is kind of the return type or the output type. If you're talking about the context of the script, like doing something like this, hello equals greeting, that actually does not get you a string. That gets you an execution result, and now you can do like standard out, standard error, exit code. You can get all these things. I wonder if this actually works. No. Member access only supported for internal structure. Okay. That should work though. Maybe if we did this, and if it's not a block. Okay, so this should work, but it doesn't. So I'm gonna try to do this. But this is how it's supposed to be working. That's not a difference. Oops. What if we just interpolate it? Okay, we get it then. For some reason there's like a slight difference here when we call a function, but basically the function should be an execution result, and it doesn't actually return the string itself. Thank you, Blue. So that's the idea. And the same thing is when you import something. So when you import, you know, we have another file then. I'll just put this back like this. We have another file, importer, that says that module equals import module rm. Excuse me. Okay, now we should be able to access greeting on this module. Of course, this doesn't work now because it's not implemented. Oh, invalid free, interesting. Okay, anyway, so this is how it's supposed to be working here, is that the module that you get is actually like an execution result, because we're kind of executing this file, gathering all the declarations, everything, and that's what you can access on this module here down. But you also have things like exit code, standard out, standarder, just like a execution normal, like if you bind to like a process execution like this, because that's what everything is. When you call a function, that's what you get, an execution result, or that's the idea anyway. All right, but that's gonna be it for this time. Welcome back. I'm going now, but mute Asimos. So yeah, that's the idea with the modules. I'm gonna try. I'll see how I am tomorrow. We'll see what happens. But yeah, thank you very much for joining me, and I'll see you later. Have a nice day. Bye bye.